નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી. Good morning, students. Today we are going to learn Standard 10th Mathematics, Chapter 14, Statistics. So let's start exercise. Good morning, students. Last time we have discussed regarding median. Now today we are going to talk about mode of the data. Here the mode of ungrouped data is the value of the observation having the maximum frequency. So what is the mode of ungrouped data? The value of observation. The value of observation having maximum frequency. Observation having maximum frequency is the mode of the ungrouped data. That will take the illustration. Then grouped frequency distribution. For grouped data, what is the how to find the mode? So here we cannot have mode directly in grouped data. Here for ungrouped data, you can have more than one mode also. There may be maximum frequency, more maximum number of frequencies. So you will have more modes. If one mode, then there may be two modes, so bimodal, three modes, trimodal, it is multimodal. But in our here there is a restriction for grouped data, we will have single mode only. So for this, first of all, by looking at the maximum frequency like this, we have to decide only the model class. So from this we will come to know the range or the class. The mode of the data lies in that range. So here maximum frequency, that gives us the model class. So to find mode, there is a formula where mode denoted by Z is equal to L plus here F1 minus F0 upon 2 times F1 minus F0 minus F2 whole bracket multiplied by H. So what are these? Mode denoted by Z, here model class denoted that we can decide from maximum frequency. The class having maximum frequency is the model class. So from the model class, lower limit of the model class is denoted as L. Then H, that is the width or the size of the class. Width or size of the class. Now what are these F1, F0, F2? So here first of all F1. F1 is the frequency of the model class, whereas F0 is the frequency of the class preceding to the model class. Model class F1, then preceding to that frequency is F0, and F2 is the frequency of the class succeeding the model class. So F2 is the frequency of the class. Suppose the model class is given, then the frequency of the next class, that is the F2. So using this also we will solve illustration. First of all, let us solve ungrouped data. Here illustration 4. The wickets taken by a bowler in 10 cricket matches are as follows. There is a bowler, he played 10 cricket matches. He took 2 wickets, 6 wickets, 4 wickets, 5 wickets, 0 wickets, 2 wickets, 1, 3 and 2. Various wickets taken by the bowler in different 10 matches. So last year also we have studied. So what is the mode? Here maximum times the observation occurs. That is here 2. And so 2 is called mode of the data. So this way also we can solve. But by writing frequency, we will prepare the table to find the mode. So first of all we will prepare here the wickets are the that will be the mode of the wickets we have to find out. So here how many wickets are taken? Minimum 0 and maximum 6 wickets. So number of wickets 0 to 6 we have to write. Now let us see 0 wickets how many times? Only one time. Then 1 wicket taken how many times? That is also one time. Then 2 wickets taken how many times? 2, 2 and 2, that is 3 times. Then 3 wickets taken how many times? 1 and 2, 2 times. Then 4 wickets taken how many times? 1 time. 5 wickets taken 1 time, and 6 wickets taken 1 time. So here various wickets taken, 0 wicket, 1 wicket, 2 wicket, 3, 4, 5 and 6 wickets in different number of matches. So here you see in one match 0 wicket, one match 1 wicket, in 3 matches 2 wickets. So from this we will come to know maximum number of matches. Here maximum number of matches 3, that is the highest frequency. So highest frequency is 3, or we say the maximum number of matches is 3, and therefore the mode of the data is observation having highest frequency. Observation having highest frequency, maximum frequency. Is it clear? So that is 2. So here the mode of the data is 2. So here 2 is the number of wickets taken by the bowler in maximum number of matches. Here 2 is the number of wickets taken by the bowler in maximum number of matches. Maximum number of matches. 2 is the wickets taken by the bowler in maximum number of matches, that is 3 matches, and therefore here mode of the data, that is denoted by Z, is 2. So here mode of the data is 2. Is it clear? This is ungrouped data. Last year also we have discussed this part. Now let us proceed with grouped frequency distribution table. Grouped frequency distribution with class with maximum frequency. So that is the model class. So here we will get maximum frequency model class. Here we will get maximum frequency mode. So let us see how to go for grouped frequency distribution. Illustration 6. A survey was conducted here on 20 households in one locality. Survey was conducted for 20 households by a group of students. So here that was regarding the family size. The family is having members, 1 member, 2 members, or less than 3 members, 1 to 3 members, 3 to 5 members, 5 to 7 members, 7 to 9 members, 9 to 11 members. So there are 7 families having 1 to 3 members, 8 families having 3 to 5, 2 families, 1 family having 9 to 11. Total survey here of 20 families was made. So here the family size. So we will get the mode in a particular range. What is the mode of the data here? Here the family members are there. 7 families are there having number of members. So number of members here, family size is the we'll get the mode in this range. So which range we will get? So let us find the mode. So first of all we have to go for the model class. As we have discussed here, the model class means what? The maximum frequency. So you can see here the maximum frequency is 8. 8 is the maximum frequency. So our model class is 3 to 5. Now model class is 3 to 5. So our mode lies in this range. That is final. Okay. So let us find mode of this grouped data. So model class we have come to know. Now using this formula we have to solve this type of question. So now you see, first of all model class. What is a model class? Model class is 3 to 5. Reason is 8 is the highest frequency. 8 is the highest frequency, and therefore the model class is the class with the highest frequency. Now lower limit of the model class is 3. Width of the class. So here you can see 1 to 3, 3 to 5. So either you take the upper boundary points, consecutive upper boundary points or lower boundary points, difference is 2, and that is called height. Now we have to calculate frequency F1, frequency of the class, model class. Frequency of the model class is 8. Frequency of the class preceding to the model class is F0, and that is 7. And frequency of the model class succeeding to the model class, frequency of the class succeeding to the model class is 2, and therefore here it is 2. So now we can find out, therefore mod is equal to here lower limit plus in bracket f1 minus f0 divided by 2 times f1 minus f0 minus f2 multiplied by class width h. Is it clear? So let us substitute the value, and therefore mod is equal to here first of all width 3 in bracket. Now f1 that is 8 minus f0 that is 7 divided by 2 times f1 minus f0 that is 7 and minus f2 that is 2 multiplied by h, and that is 2. So now therefore we get mod is equal to 3 plus here 8 minus 1 that is 8 minus 7 that is 1, 2 8 is 16 minus 7 minus 2, 16 minus 9 that is 7, 16 minus 9 that is 7. So 1 2s are 2, so we'll get finally 2 by 7. So now 2 by 7, that means here the mod is z is equal to 3 plus here the 2 by 7 we can convert into decimal point, and that is 0.286, and therefore the mod is 3.286. So here the mod of the data is 3.286. It lies in this range. As I told, model class 3 to 5. So mod of the data here 3.286. Dear students, in illustration 6, the marks distribution of 30 students in a mathematics examination are given. Their marks distribution of 30 students is given here. That is, there are 2 students having scored marks 10 to 25. There are 3 students having scored marks 25 or more than that but less than 40, that is 25 to 40. 7 students having scored marks 40 to 55, that is 40 or more than that but less than 55. Similarly, 6 students in this range, 6 in this range, 6 in this range. So here this distribution of 30 students in a mathematics exam, marks distribution is given here. So we have to find the mode of this data. What is the mode marks? Here what is mode marks? And after finding the mode, we have to compare and interpret the mode of this data and also mean. The mean of this same question, mean of this data we already calculated, and that was 62 in illustration 1. So we will interpret and compare the mode and mean of the same data. So let us start the solution for mode first of all. Here for mode we need to find model class. So here maximum frequency is 7, and therefore model class is the class having highest frequency, so that is 40 to 55. So model class, to calculate the model class we need to go for highest frequency. The class having highest frequency is called model class. So once we know the model class, we can go for the lower limit of the model class. So what is the lower limit of the model class? That is L, and lower limit of the model class is here 40. So lower limit of the model class is 40. After writing the lower limit, we have to go for the frequency. That frequency of this class, that is F1, it is 7, and then F0, that is the frequency of the class previous to this class, is 3, and the frequency of the class next to this class, that is 6. So this is the model class frequency, that is F1. So this is F0 and this is F2. So here it is F0, F1, F1, then this is called F0 and here it is F2. So using this data, let us find out mode of the data, and therefore mode is denoted by Z, and here L plus F1 minus F0 divided by 2 times F1 minus F0 minus F2 multiplied by class width. So here class width, you can see upper limit 25 and here 40, or any successive upper limit you take. So 55 and 40, so difference is 15, and so the class length here is, or the class width is 15. We need this also. So now therefore we say the mode is equal to, here L is 40 plus in bracket F1, F1 is 7 minus F0 is 3 divided by 2 times 7 minus F0 minus F2 multiplied by 15. So therefore Z is equal to 40 plus, here 7 minus 3, that is 4 divided by 14 minus 3 minus 6, that is 5 multiplied by 15. We can cut the common ones and thus we get Z, that is mod is equal to 40 plus 4 3s are 12 and that is 52. So thus the mod is 52. Now here we got mod is 52. So what do you mean by mod? Our question now, after finding the mod, compare and interpret mod and median. So first of all, what is mod? Actually mod means what? Here for this data, maximum number of marks, maximum number of students here, out of these students, maximum number of students, they have obtained this 52 marks. 52 is in this range. You can see, as we know the here model class, our mod lies in this range. So that is marks. So 52 marks. So maximum number of students obtained, 52 marks. So mod means, here mod means, mod is 52. Mod is 52. That means maximum number of students obtained 52 marks. At the same time, for the same data, mean we have calculated in first illustration, and that is 62. So what does it mean? So what do you mean by mean? So mean means here average. Here 52 marks we got, that is highest number of students, maximum 52 marks obtained by maximum number of students. Other students either got less than that or more than that, but maximum are in this, that is 52 having scored this or nearby. Mean means what now? That is on an average, marks obtained by the students on an average. So on an average students here, on an average students obtained, how many marks here? 62 marks. On an average students obtained 62 marks. So this is the meaning of mean and mod. Now we are going to discuss next time median. So we will discuss what is the meaning of median also.
Thank you for joining us.